I was a chemical engineering student, and in the middle of my third year, I had this realization that faculty are never taught how to teach. And this shocked me because I thought, isn't that a big part of their jobs?
The principal model of engineering teaching prior to this work was the content expertise idea. You have a PhD in a discipline, you are an expert in the content, therefore you can teach it. And it's a reasonable, plausible assumption. It just happens to be wrong.
The traditional way of teaching was several hundred students in a large lecture theatre and maybe some small lab groups afterwards. And we've known for 20 or 30 years the evidence is there that that doesn't work. The way to change it is to move to what's called active collaborative learning, where you have students more in teams, accountable to each other, and to the class generally for what they're doing. And so we moved to a situation where we had students in teams of 4 because we just know that there's more effective learning.
With our in-class activity for today, we are going to be thinking about paper clips. First question is, how do we know if a paper clip is good? It's durable, it's malleable, you can bend it, okay?
3, 2, 1, go. 7.94 seconds.
You are the outlier.
Good enough.
24 seconds.
You can write on all the walls, and so over here you can see somebody actually doing that, developing their ideas, brainstorming on the walls.
Sure, this is a general diagram of our initial design for our roller coaster. From a large drop, so we're going to gain a lot of velocity, go through a vortex, and then hopefully loop back, and then through the vortex again.
What do you think? Do you think it's outrageous or something?
Well, yeah, it seems outrageous.
It's not.
But the main thing you see here is it's just the general kind of buzz of activity where people are actively involved in the learning.
I like it. I love working with a group. It's always because you get so many new and different ideas you never think of.
We've designed tools to support the management of teams in the classroom. We develop tools to form teams so that they have a better chance of being successful. Specifically, women, because they're outnumbered in engineering and because of the way the dynamics are in teams, men will frequently interrupt women if they are outnumbered on a team. So if a woman ends up on a team of 4, then we make sure that there are 2.
The first thing I tell to my students is that there are no perfect teams. All teams have problems. That good teams are able to identify those problems and do something about it.
You know, the students who deal with problems with their team, that's going to prepare them much better, you know, for their career, where they're going to be working in teams, not only people who, people in the same company, but people in different countries, people all over the world. And I think that experience can be very valuable.
I honestly don't know if I would have still been in engineering today if I didn't have that experience. It wasn't just about the MATLAB, the technical skills, everything like that. It was all about learning how to work with a team. It was learning about how to share engineering with other people and learning what engineering really was as a whole, not just sitting there designing.
Kamyar was bigger than life, and he had a vision that was like the sun, and you couldn't help but just follow behind him. We were out at a restaurant, and he went around to everybody and said, name 5 people if you could hire them. Didn't matter if you could actually hire them, but who those movers and shakers in engineering education were at that time. And he wrote them down on this tablecloth, and for the next 2 years, every once in a while he'd pull out that tablecloth and he would have crossed one off because he got him to come to Purdue.
As I looked at the program develop, it really started to look like an artist colony. It looked like an opportunity to come and be with people who I already knew and who I knew were doing great work, but who now were suddenly all in one place.
And then I found out that Purdue was hiring. And I picked up a job ad at one of our disciplinary conferences, Frontiers in Education conference. And I talked with a couple people from Purdue there. And I left completely jazzed, so psyched about the idea that there was this developing discipline of engineering education where there were graduate students and there were faculty and staff, and everyone cared about engineering education specifically.
What it takes to learn to become an engineer, or even to discover engineering when you're in kindergarten or at school.
My interest has gotten to be in K through 6, because I think that's where the kids either get enthused and interested in math and science, which is the foundation for engineering. If you don't get them early, you don't get them.
A great example right now is actually on Friday, I went to a preschool. So this is 2- and 3-year-old kids. We took some puppets and said, okay, when it's raining outside, what can you do to help protect the puppet from the rain? And then we had them build a house out of the blocks and discuss what the house needs to be able to do. So we did a very simple design exercise with the puppets and with themes that they already knew. And the teacher says that later in the day, after we had left, they were still building houses for their puppets and trying to figure out how they can keep them protected from the rain. So I'd say that was pretty successful.
One of the nice things about this room is the glass walls that go around the room. So we literally have teams of students lined up for their 10-minute turn to come in and demonstrate their project, watching the other teams go through the same thing. So it really helps with that transparency and engineering theme that we like to talk about with our students, that your work is going to be viewed by others and has to be open to constructive criticism. What James is doing here, he has designed a part and he's manufacturing it here on the computer. This is the machine removing the material just like it would inside the manufacturing lab. We design and manufacture the parts on the computer, simulate it both on the computer and then on the simulator that runs the machines, and we make sure the program is going to work over here before we take it to the other side of the hall.
In essence, it's a place where students come to build parts for whatever project they're doing. And the real agenda is that they're learning as engineers what it takes to get something made. So we don't train them on the machines in the sense of do these training courses. We don't run labs in here. What we do is we say, okay, you want that part made, you've designed it. We'll assign someone to work with you so you can learn how to use this machine to make your part. In the process, they will appreciate what it takes.
Engineering these days involves many disciplines, not just different engineering disciplines, but might involve architects or social scientists or a whole range of people. But in the future, we will need to attract a broader range of people, a more inclusive set, something that better reflects the society. And so things like multidisciplinary engineering that we run here and our sort of research in engineering education is attracting people who don't fit the traditional molds.
Engineering turns out to be a really useful education no matter which direction you're headed after you get out of school. For example, I became a Hollywood screenwriter, and it turns out people say, how did you get from studying aeronautical engineering to screenwriting? It's very simple. Engineering teaches you how to find out things and how to measure them, how to apply them, and how to test them.
That successful professionals in the future are going to have more than just technical depth. They're going to have other kinds of skills. Some folks are now calling this the T-shaped person, people who have some technical depth, but who have this much broader range of skills, who have language experience, who have internships experiences in a variety of places, who can navigate complex kind of settings.
The kinds of projects that we have students do are collaborative, and they're not necessarily competing against each other, but instead we put them into situations where they provide feedback to each other.
For this particular project, what they've been given is a design task that's familiar to them. It's about a street corner out in front of our building in which there's been a fair number of accidents. And their job is to try to understand what's really going on and to come up with a solution.
So they have to look for traffic from the left. And then they also have to be worried about pedestrians crossing here. And then if they're going to turn here, what about pedestrians crossing here? I mean, there's so many different factors that cars there need to consider it.
What if you saw a sign like this?
Are you guys going out to the street?
Okay.
Yeah, we'll be right with you. Hang on.
95 seconds on a moderately busy.
That's a long time.
That is.
About 2 minutes
cold.
of waiting. Unless somebody.
I think make this a more comfortable place to wait, since we have the space. It wouldn't be low cost.
This is the open house for School of Engineering Education. The idea is we bring people who are interested in possibly doing a PhD to come meet us, talk with us, hear about the research that's going on.
In empathic design, you actually get to know your user, your client, and you get to know really what they need and what they want and what's going to work for them. And then you design it, versus just designing something and maybe going and advertising it and saying, here, this is good for you and this is why.
I went and taught engineering to students in Japan for the last 3.5 years. I learned that the education systems are very, very different. And I learned that there's not that much research going on in engineering education. I mean, there's some, but it's not the kind of field where everybody does the best practices based on the research.
So we're trying to transform the way in which we educate engineers. And the key is we have an integrated approach. So it's this cycle that feeds on itself. Just doing innovation on a hunch is not going to get us very far. Just doing research without application doesn't get us very far. So it's this combination, this virtuous cycle of research and educational practice.
I think this may be really the most significant breakthrough in this whole concept that they've come up with, and that is the idea of engineering education being used to analyze education and re-engineering education itself across the board. That testing and reviewing and designing and testing is the magic formula for fixing problems. And there is no reason why they can't turn that lens on education itself.
As engineers, we approach problems differently, as you said. We want to kind of create a theory, but we also, when we see changes, we question them, and we try to find root causes, or we try to describe what's happening. And so I think that interest in how we like to tinker and build things and play with things, I think that perspective is what allows us to kind of approach education differently.
Well, they gave us a list of animals to choose from, and we were supposed to build a robot that replicated the movement of that animal. And so we picked a turtle because we liked the way that it moved, and we thought it would be the simplest to build.
This looks like a lot of fun.
It's important to engage them in thoughtful engineering activities such as analyzing and then in troubleshooting and problem solving as part of their process, right? So the fun is getting their bot to do a certain thing, but it's also getting it the systematic thinking that goes behind getting the robot to achieve that particular function.
Tonight I'm announcing a new challenge: to redesign America's high schools so they better equip graduates for the demands of a high-tech economy. And we'll reward schools that develop new partnerships with colleges and employers and create classes that focus on science, technology, engineering, and math. The skills today's employers are looking for to fill the jobs that are there right now and will be there in the future.
I explicitly identify my research as feminist, as critical, as connecting with social justice. And there aren't that many places, I think, in the country that would support such a arguably radical agenda in such a fairly conservative profession as engineering.
There is a great push now to look at the professional skills development of engineering students, not just technical skills, and one area is leadership.
Every week we meet for dinner
dinner at 5:30 on a Wednesday because we want to have a social life outside of our learning community. So if anybody comes to the dinner with problems or questions, we try to resolve those and help them out.
I think it really brings the family together.
Because we share so many interests and we just hang out with each other all the time, they're kind of your home away from home.
If you don't get them early, you don't get them.